that we got through that calculus, let's jump into some Chapter 3 review, and it'll be quick.
To find if f prime of 2 does exist, we must take the derivative of f of x. To do this, we must take 8/9, move it to the front, so it is a coefficient now, and then in the exponent we must take 8/9 minus 1, which results in a negative 1. So the derivative of f of x is 8 over 9 times the 9th root of x minus 2. So we find out that the derivative of f of x when x is 2 does not exist. Divide by 0. To find dy dx for y equals cosine of the arc cotangent of e to the x, we must use the chain rule.
All you need is the chain rule. Identify the in, identify the out. You don't need a tool, just do the chain rule.
If we take the outside, which is cosine, which results in negative sine times the inside, then we take the derivative of the inside, which results in the derivative of the arc cotangent of e to the x, and then we multiply by the derivative of the inside again, which is e to the x, which results in just e to the x. And we take all those, multiply each other, and we get dy dx equals e to the x sine of the arc cotangent of e to the x all over 1x minus 12xy, e to the 2x. In example 3, we must use logarithmic differentiation in order to find dy dx for y equals x raised to the power of secant of x. Now, in order to do this, we must take the natural log of both sides, and by the logarithmic property, we can move secant of the x into the coefficient position, natural log of both sides, and by the logarithmic property, we can move secant of the x into the coefficient property. Secant of x, tangent of x, natural log of x. Now, since we have y prime over y on the left, we multiply by y, and we result in x secant of x, all distributed to secant of x over x, plus secant of x, tangent x, natural log of x. And that is y prime, which is also dy dx. For example 4, there are two ways we can go about to find dy dx for y equals the log base 6 of 2 to the x. First way we're going to go about this is the chain rule.
All you need is the chain rule. Identify the in, identify the out. You don't need a tool, just do the chain rule.
And this results in 1 over 2 to the x, natural log of 6, that multiplied by 2 to the x, natural log of 2, and 1 over 2 to the x, natural log of 6, which is derivative of log base 6 of 2 to the x, derivative of the outside, keep the inside. The second way is to use one of the logarithmic properties, where we can move the x down into the coefficient spot, and we have y equals x log base 6 of 2. So we must use the product rule. So we take 1d2 plus 2d1, and that results in x over 2 times natural log of 6 multiplied by the derivative. So dy dx equals log base 6 of 2 property. We can use the change of bases, which for the final example, we must use implicit differentiation in order to find the second derivative of x cubed minus y plus y squared equals 73. In order to do this, we must take the derivative of both sides with respect to x, but when we take the derivative of the y variables, we must have them also respect to x, but since they are not x values, we multiply them by y prime to keep them with respect to x. When we go through all the calculations, the result of the first derivative is equal to negative 3x squared over the quantity of 2y minus 1, or if we take a negative out, we get 3x squared over the quantity of 1 minus 2y. Now, this is only the first derivative. We need the second derivative, So we must do this process again. In order to find the second derivative, we must use the quotient rule, which is low d high minus high d low, all over low squared. But since when we take high d low, one of the derivatives result with a y prime, we just take what we know from the first derivative, plug it in, and then solve for the second derivative. So we get the quantity of 1 minus 2y multiplied by 6 to the x plus 3x squared multiplied by 2y prime all over the quantity of 1 minus 2y squared. So we use the distributive property to get 6x minus 12xy plus, and then since we have the 3x squared multiplied by 2y prime, we double the first derivative multiplied by 3x squared. So we have the 6x minus 12xy plus 2 times the fraction of 3x squared, quantity squared, all over 1 minus 2y, and then that numerator is divided by the quantity of 1 minus 2y squared. Now, in order to get like fractions, we take the binomial of 6x minus 12xy, we multiply that by the first derivative. So, the second derivative equals, in the numerator, the quantity of 1 minus 2y foiled by the binomial of 6x minus 12xy, and then that is added to 18x to the fourth, and then all of that is divided by the quantity of 1 minus 2y quantity cubed.